Hi everyone, welcome to the webinar. We're going to get started. So today's webinar is called Balancing the Chemistry of a Car Wash. Everyone has been placed on mute to eliminate background noise, and we encourage you to use the questions box during the presentation. We will be recording the presentation and have it available in the next few days for you. So let's cover some association business. The next events coming up are the Arizona Self-Serve Summit and Roadshow on November 14th and 15th, followed by 2018's California Law Update on December 7th. Now let me introduce you to the speaker, Stuart Holsley. He is a technical chemistry applications consultant working in the car wash industry since 1988. Specializing in how chemistry relates to and works with the other various parts of the car wash process. Stuart has a degree in chemistry and physics from the University of North Georgia and has been with ZEP Vehicle Care for 24 years and is currently the technical service manager for the organization's Vehicle Care program. Now, let me turn you over to Stuart.
Thank you very much, and welcome everyone to the webinar this afternoon. We thank you for taking the time to join us. Let's get started. Since you know who I am, we'll just get right on into our discussion today, balancing car wash chemistry, balancing the chemistry of a car wash. So first of all, we have to ask ourselves, what are we looking to do? So kind of an overview of what we're going to talk about in the next 35, 40 minutes is something we refer to as the 5 factors of cleaning. We'll also talk about some product chemistry, and we'll also talk a little bit about water and how that plays a factor into all of this balancing the chemistry of a car wash. So let's look at the 5 factors of cleaning. What are the 5 factors of cleaning? We like to look at the 5 top things of time, temperature, mechanical action, chemical action, and procedures. Those 5 things evolve around a pie chart, as you can see on the screen there on the right. And as you all know, a pie chart adds up to 100%. So we'll see here in a minute how that plays into our description of how these 5 factors of cleaning really affect the balance of a car wash and the chemistry in a car wash. So we like to say maximum cleaning requires all of these factors to work together. And since it's a pie chart, 100%, reduction of one will require an increase in one or several of the others to make up that difference. And you'll see that when we start talking about the water temperature and the chemistry strength and things of that nature. So just a quick review of these 5 factors. Time. So what is time? Dwell time is what we like to look at it as, and how it affects the chemistry. In general, the longer you allow a detergent or soap to sit on the surface of a car, the better it's going to work. However, there is a point, as we show on the screen there, of diminishing return, if you will, where the soils may actually start to redeposit themselves back onto the surface. We call that redeposition. We'll see a little bit later on what we mean a little bit more about redeposition. But we like to say the optimum dwell time in general is going to be no more than 30 to 45 seconds. It's going to differ in a conveyorized wash over an in-bay automatic wash, or even if someone's has a self-serve where a person is out doing it themselves, the contact time can be even longer than 30 to 45 seconds. But for conveyors and automatics, we really like to say no more than 30 or 45 seconds before the product, either through evaporation from heat or just the fact that the detergent starts to allow the soils to reattach to the surface of the car, and you begin to lose that effective cleaning chemistry on the car. So that's the time. The next one is temperature. we look at 3 different types of temperature. We look at the ambient temperature, which is the air temperature outside. We also look at the surface temperature of the vehicle, whether it's a cold day or it's a hot August day and the temperature of the car is on up in the 150, 200, 250 degree range. And then the third area we look at is the chemistry, the product in the water, and really more specifically the temperature of the water, whether you need hot water, cold water, and how that affects the cleaning of the chemistry. And one thing specifically on the temperature, as you see there on the screen, the effects of temperature. Temperature really equals activity. The higher the temperature, really the better it cleans. We all know about cleaning dishes at home, if you will, and cutting grease and oil. Everything cleans better with warm to hot water versus cold water. But there are some limitations. And you see our general guidelines are in the 120 to 130 degree range. Some may go to 140. The key is you don't want to have your water temperature so high that it starts to break down the chemistry. And there's a limit on a lot of chemistries, and 140 degrees Fahrenheit is kind of the line in the sand that a lot of chemistries will start to break, just raw materials in general. No matter whose product it is, the raw materials will start to break down in that 140 degree range, and you'll lose the cleaning effectiveness of your product due to the heat of the water. So those are the 3 areas of temperature that we want to be aware of in the 5 factors. The next one is mechanical action. There's generally 2 types of mechanical action. There would be friction, which is your cloth or brushes, closed foam cell, and things of that nature. Also touch-free washing, where the friction or the mechanical action in touch-free washing is really the high pressure. And the impingement, if you will. And the impingement is where the water droplet collapses on the vehicle surface, creating that friction to help clean the soil off of the surface of the vehicle after the chemistry has loosened it up and done its job. And speed of the cycle, whether it be conveyor speed of the conveyor speed of a tunnel, or it be the pass speed on an in-bay automatic, speed of cycle determines cleanability as well on mechanical action for a touch-free application. And for a friction application too. If you're going too fast and don't have your brushes and all adjusted, it could swing out and you could miss some side areas on a vehicle. The bottom line on the screen there, good preventative maintenance program, that's critical. That is critical. You want to make sure that, as I said earlier, your friction, your cloth is adjusted properly where it's touching the vehicle right, or it's not touching too strong to rip parts of the vehicle off, but it's just right. But also that all the mechanical parts of your wash are working well. And one good example that we'll show you is something a lot of people don't think about. It's your nozzles. And it goes along with pumping. It goes along with pumping your pit. Man, I know I pumped our pits about 3 months ago, and then when you go back and look at the invoice, it was 8 to 9 months ago. And man, how does that time pass so fast? Similar things can happen with your nozzles. We've got some examples on the screen of some nozzles that are clogged at 5 magnification and 35 magnification that are just worn out nozzles. Worn out nozzles can, and or clogged nozzles can affect your cleaning with poor application of your chemistry. It can also give you issues with high pressure cleaning. So just good maintenance is the key on the mechanical part of your wash. Now, one of the big parts of the 5 factors of cleaning is chemical action. And that's what we're going to spend a good bit of time on that today. But chemistry, and a good definition of chemistry is the combination of a chemical solution with water, and then the ability of that mix to clean all the different types of soil that you see on a regular basis in a car wash. And speaking of soils, there's two major types of soil that we deal with. We deal with organic and inorganic. Organic materials are bugs, bird droppings, tree sap pollen, all the things in this world, grease and oil, things that used to be alive at one time. Inorganic is going to be your mineral type soils, break dust, salts, clay, calcium, concrete. That's why you always go to the store and get an acid to brighten the concrete and clean the concrete, is because it's an inorganic material, and an acid cleans the inorganic material best. So chemistry is a key thing on your chemical action and picking the right one. The chemical action is needed, or the chemical action, the actual functionality of the chemical is to break down the soil's physical bonds on the surface and reduce the static charge that in turn releases the soil from the surface. When you go over the surface with your cloth or your closed cell foam, or it's a high pressure touch-free automatic. So, and I know the age-old question is, what's the charge of a vehicle going down the road? It's always been, we've always been told it's a positive charge. So a vehicle going down the road does create a charge which will attract soil, and so you need to use the right chemistry to break that static charge and release that soil from the surface. So the last thing of the 5 factors of cleaning is a very general one. It's procedures. And as you can see, it's basically all the activities that are required at a car wash, whether it be a full service where they prep and dry and do your detailing at the end, inside and out, or it's a hand wash, or it's an in-bay automatic where you have one person that's monitoring the wash and keeping it clean and making sure everything's working right. Procedures are all the human activities that happen at a car wash. So just kind of in review of the 5 factors, you can see there's, again, time, temperature, mechanical action, chemical action, and procedures. And again, as I said earlier, a decrease in one of these factors means that one of the others, or a combination of the others, have to take up the slack to complete that 100% in the pie chart to make sure you have effective cleaning. So the next thing, so that's the 5 factors of cleaning. The next topic we'll talk about and spend most of our time today is car wash chemistry. So car wash chemistry is basically about balancing high and low pH components or products, which in turn remove the soils from the vehicle surface. Car wash chemistry is also understanding the soils that are on the car and the water that's used to clean with and rinse with, and also how they affect the cleaning process. And then one last one is how the wash process, and when I break this down, I say wash process, how the wash process affects the finishing process. In a car, in the car wash, you clean up front and you seal, protect, and finish at the end. And this car wash chemistry has kind of multiple facets to it. It's about the cleaning part in the front, and it's also about the protecting and finishing part in the back, but it's also about how the cleaning chemistry up front relates to and deals with the finishing chemistry at the end. Those two have to get along, or you will not have a good car wash. So the ultimate goal on this car wash chemistry is to produce a clean, shiny, dry car, resulting in happy customers that return time and time again. And I guess I will maybe stop at this point. Is anyone have any questions or comments? Okay. I don't see any questions come in just yet. We'll look for that again in a few minutes. So let's talk about the wash. Let's break this up and let's break the car wash up into the first part of it being the wash process and the second part being the finishing process. Let's talk about the wash process. There's a balance, there's an internal balance to the wash process. And the wash process has several different things we want to look at. We want to understand the pH, high and low. So really, what is pH? That's a question we're going to look at. What is pH? And then we'll look at high pH products versus low pH products. What are they? What do they do? What soils do they remove? So on and so forth. And then the third thing we'll look at is the lubrication step, or the lube soap. Lube soap is really surfactant, and there's several different types of surfactants. And the surfactant that is used depends on whether or not you're going to get the optimum car wash. A surfactant can be in a product that's either a high, low, or neutral formulation, but the surfactant itself really is a determining factor of how well your wash is going to clean and how well it's going to rinse and dry. So those are the three things in the washing process. And then also we'll talk about how the wash part balances with the finishing part to get that clean, shiny, dry car. Okay, pH. A good simple definition is pH is a numeric scale that measures a solution as either acidic, neutral, or alkaline. And we have a nice little chart here, a little diagram that shows you all the way to the left at a pH of 0. The scale goes from 0 to 14. At a pH of 0, you're looking at battery acid. Your drinking sodas and lemon juices and things of that nature are in the 2.5 range. Your water is in the 4 to 7 range, with distilled water being 7 at neutral. A good clean rain is in the 5 range, but acid rain is actually down into the 4s. Then we get above the neutral line on the alkaline side. You can see blood and seawater and baking soda are in the 7 to 9 range. And then getting on up really strong, we have ammonia, bleach, and a caustic drain cleaner, which is in the 11 to 14 range. So that just kind of gives you an idea of the pH scale and what the pH scale is. One other thing about the pH scale is that it's not to get too technical, in the math world, it's referred to as a logarithmic scale. So a pH of 8 is 10 times stronger than 7, and a pH of 9 is 10 times stronger than 8. So that makes the pH of 9 100 times stronger than 7. So it goes logarithmically from 7 to 8 to 9 to 10. It goes 10 times stronger, 100 times, 1,000 times. 11 would be 10,000 times, and then 12 would be 100,000 times stronger than 7. So that kind of gives you an idea of how the pH scale works. And just one other thing about pH. pH is not really used for dilutions. You may have seen out in the field where someone says just set your pre-soak to a pH of about 10.5. That could be 50 to 1, and it could be 100 to 1. Unless you have a digital pH meter, there's really no way to tell the difference between 50 to 1 and 100 to 1 just doing pH. The best way to dial your chemistry in is through actual titration, to where you can actually tell a difference between 90 to 1 and 100 to 1 on a pre-soak or a wheel cleaner or something of that nature. So that's understanding pH and how that works. All right, so let's look now at high pH products and low pH products. So what are high pH products and what do they do? High pH products break down the organic components, the oily, greasy things in the world that used to be alive, if you will. So they get rid of the oily, greasy materials. They also do what we say wet and penetrate. So they will wet and penetrate the soil, so it will lift up off of the car and it will be released and suspended so your rinse cycle can wash it away. So that's where it suspends the soils and the road film so you can rinse it away and give you that clean, shiny car effect. Alkaline products also neutralize acidic things, acid rain, tree sap, bugs, anything on the acidic side. Some alkaline products actually contain buffers in them to help protect soft metals like aluminum and things of that nature from getting an alkaline burn on a hot day from a high pH caustic-based pre-soak or something of that nature on a very hot day. So high pH products can be used for that as well. Low pH products. So what do low pH products do? Low pH or acidic products, they break down inorganic materials, water spots, limestone, which is calcium, also clays and things of that nature. And out in the West and the Midwest where you folks are, there's a lot of clays and bentonite clay and things of that nature. So you would be looking at a low pH product to help you make sure that you can get all those soils and all off of the vehicles on a regular basis. Low pH products traditionally increase the shine of a painted and chrome surface. Also, they make glass really nice and shiny. In very hot areas, you can use a light solution of a low pH to cool down a car if it's really hot in some areas, and that would help prevent that alkaline flashing. Low pH products have excellent rinsing properties. They aid in the drying process. So those are the key things on low pH products. So now let's get to one of the real foundational points in this balancing of the car wash is your lubrication products or your lubricating soap. It's all about the surfactants. You utilize the surfactants to aid in the cleaning process, and there's 4 different types of surfactants that we'll talk about today. So, but the type of surfactant that's used really determines what kind of wash you're going to get and how the finishing product, how the end product is going to look. So surfactants in general, they will break the surface tension of the water, allowing the detergent and the soap to penetrate the soil and lift it up off the vehicle surface and make it available to be flushed away through the rinse cycle. Lubrication products also prevent scratching and dulling of painted surfaces. Some surfactants increase the shine of paint and chrome and glass. Some surfactants improve rinsing. Some surfactants increase the surface tension, helping in the drying process. So you're beginning to see in just this one slide, the first bullet point, the surfactant breaks the surface tension, making the water want to lay flat. But also the surfactant in the last bullet point increases the surface tension of the water, making it want to beat up and roll off the surface of the car. So let's break these down a little bit and look at the differences in why you would use a certain surfactant where. Let's start at the front of the tunnel with the cleaning process. There's a couple of different types of surfactants, and what these surfactants do, and as I said earlier, we would get to the word redeposition. What happens is a surfactant will emulsify the soils on the car, but if they don't hold on to it long enough and keep it emulsified, the soils will start to break away and release again, and they can actually reattach themselves to the car before you get to the rinse process. So a good cleaning surfactant will keep everything emulsified, lift it off the surface, and prevent it from reattaching until you can get through the rinse cycle and start your finishing applications. There's a couple of different surfactants. The first one is what we refer to as an anionic surfactant or a negatively charged surfactant. Those are used for lubrication. They're really high foaming. They're free rinsing. They lift the soil up off of the surface and they hang on to it until you can rinse it off. But they are not that compatible with sealants and drying agents. And you probably heard that your anionics and cationic surfactants, some soaps and some drying agents don't get along with each other. The anionic surfactant is the one that doesn't get along with your drying agents very well. Another cleaning surfactant is referred to as your non-ionic surfactants. They are neutral. They have the prefix non, which is neutral, no charge surfactant. These are more medium foaming surfactants. They don't have a lot of lubricity, so they're usually combined with the anionics in your pre-soaks and things of that nature to give you a good cleaning. But you'll also see on a non-ionic surfactant, it's harder to rinse. It doesn't rinse that well when you're trying to get it off the surface of the car. So a non-ionic surfactant is one that you would not want to use late in the process. It would start to give you conflict with your sealants and drying agents of wanting the water to bead and roll off the car. But they do give great degreasing properties, and they're good cleaners. So in your soap area, you're going to have anionics and non-ionics for cleaning of pre-soaks, wheel cleaners, and some lubricating early in the process. Here's a good schematic or a graph, if you will, that shows surfactants in the cleaning process. The water droplet on the left is just water, and you can see it sits up real high. Very little of the surface of the droplet is touching the vehicle surface. And then the example on the right is the water droplet with a surfactant, and you can see this is an example of where we call low surface tension, or it's breaking the surface tension. It wants that droplet of water to lay flat on the surface so we can get the maximum penetration of the cleaning product to get all the soil off the car. So let's now look. We've talked about the cleaning process up front. Now let's look at the surfactants that are involved in the finishing process at the back end of the car wash. We have a couple. The first one is what we refer to as an amphoteric surfactant. It can be a positive, it can take on a positive or negative charge depending on what type of formulation you put it in. If you put it in a formulation that is alkaline, as in a pre-soak, it's going to want to take on the characteristics of the surfactants we just talked about, anionic and non-ionic. It's going to want to lay flat so it can penetrate and clean, but it's not going to facilitate beading of water very well. It's high foaming, it's good lubricity, and it's compatible with all other surfactants. So that's an amphoteric. Now, if you take the amphoteric surfactant and put it in a low pH formulation, the most popular is the triple foam application. When you put an amphoteric surfactant in a triple foam application, it takes on the positive charge characteristics, and it wants to bead, or that water droplet wants to sit up on top of the surface. You're still going to get high foam, so your triple foam product's going to show very well. You're going to get great lubricity if you run your triple foam through a curtain or some wraps or something of that nature after the application. And it's going to rinse very well because it's a low pH environment, and it's not going to leave a residue. You won't leave your triple foam around luggage racks and trunk lids and things of that nature, around firewalls at the bottom of the windshields and all those areas. So that's an amphoteric surfactant. And the last surfactant that we normally see in a car wash is our cationic, and the cat prefix is a positive charge. So it's a positive charge surfactant, and that's the one that is traditionally used in everyone's formulations for drying agents, sealants, and things of that nature. And again, the cationic in the drying agent sealant is the one that's not real compatible with anionic surfactants. You can you can balance a little bit of both in a car wash, especially if it's reclaim. But if you use too much of one or the other, it can throw the balance of the reclaim off, and that's when you start seeing some of the black slimy crud at the top of your curtains, and you start having other issues when you get that balance, when you lose that balance in the reclaim type situation. So cationic or surfactants in the finishing process, your cationics and your amphoterics, they help for what we refer to as substantive bonding. They want to grab onto the surface, and then they'll have the other end of their molecule will stick up in the air, which helps to repel water, so you can rinse and get water off the car very quickly. It helps with the fast watershed with the hydrocarbon oils and things that are usually put into the formulation. These type formulas are usually neutral or low pH, so that you can counterbalance any potential spotting with hard or high TDS water if you don't have an RO unit. And a lot of the surfactants tie in well with some of the extra service products like sealants, protectants, total body protectants that have extra polymers for protection after the car leaves the car wash for several days and weeks. Here's a good example at the bottom of the screen of how these cationic and amphoteric surfactants attach to the surface of the car. And you can see the positive charge, the positive end of this molecule wants to attach to the vehicle surface, with the other end sticking up, which in turn allows the water to bead and repel and wash and roll off the car very quickly. So in the finishing process for extra service and finishing products, the cationic and amphoteric surfactants, they help sealants and protectants to protect the finish, provide shine, and then drying agents, they help them to remove water, saving time and labor and increasing the throughput of the car wash. So just kind of summarizing this chemistry and the balance, it's very important to choose the proper cleaning products, high and low, to target your soils. If you have some clays and a lot of inorganic material, you want to make sure to use a low pH product. If you have a lot of greases and oils, if you're around an airport that's got a lot of fallout from jet exhaust, things of that nature, you're going to be dealing with a lot of hydrocarbon and alkaline soil. So you want to make sure you use the right combination of products. And then another big key is to make sure you use the proper lubrication soap. And you ensure that you're not interfering with the finishing process. One of those anionic surfactant-based lube soaps is great up front, but the farther you get toward the end of the wash process, the more you want to migrate to one of the lubricating soaps that have an amphoteric base to it that will be a high foam, a high lubricator, but at the same time will facilitate drying versus wanting the water to lay flat so it can clean. Same thing with some of your extra service products with your triple foams. And that's the key that a lot of people don't realize. There's a couple of different types of triple foam. There is a regular soap-based triple foam that can be used at the front of the wash process. Some people put their triple foam really up front. And if you do that, it's best to have one of those anionic, non-ionic surfactant bases up front to get good lubrication, good show, and those are a lot less expensive than the amphoteric soaps that are at the end, where you want it to be a fast-breaking foam, a low pH application that's going to facilitate the drying. So that's what the balance is about, to make sure that you use the right soap in the right place throughout the tunnel washing process. So we talked about the 5 factors. Now we talked about the chemistry. And now the last thing we'd talk about is water. Water is important. It's always a consideration. We use it, we dilute our chemistry with it, we clean with it, we rinse with it. In a car wash, it's the lifeblood. We do everything with the water. So let's talk a little bit about the water. There's some major factors that affect water performance. The big key ones are hardness and total dissolved solids, or TDS. Hardness is the mineral content, the calcium, magnesium, and things of that nature. Total dissolved solids are not just calcium and magnesium, but everything, all the organic and inorganic content that could be dissolved in the water. There's actually a test that can be run to see if your water has alkalinity to it. And if there's alkalinity in the water, can affect how well it dries. So if you have highly alkaline water, and there's some parts of the country that have highly alkaline water. If you have alkalinity, and you can see the bullet down there, total alkalinity, high alkalinity water will result in the beads, the water not beating up and rolling off like a squeegee. It just breaks up into what we refer to as micro beads, into millions of little bitty beads, and then the blowers just move it around, but it never comes off. So that could be, that would be one area where I would look at my water, the quality of my water, to see if I can improve that to get a better drying performance. Some other things on water treatment, whether or not you do RO, whether or not you incorporate your reject water, your RO reject into your system, whether you soften your water or just use regular tap water from the city, whether or not you're reclaiming water. So there's a lot of different questions and factors to look at here. So let's look at a couple of big ones right quick. Water hardness. Water hardness is the decreased ability of the chemistry of a cleaning product to clean and wash a vehicle. Water hardness will also create scale. As you can see on those nozzles we showed a little bit before, they had some scale built up around them that can change the coverage of your nozzles. It can change how the product, how your product is diluted. It can change a lot of things. It can make foamers not work. So scale formation is a very important thing about water hardness. And then another thing a lot of people don't think about is decreased energy efficiency. A lot of heating elements in a hot water heater or in a heating system for your water, for your pre-soak, if it starts to build calcium around the element, it's going to decrease the ability for it to heat the water well, and eventually it's going to burn out the element that you'll have to end up replacing. And then, of course, the nozzles we talked about a little bit earlier. It's always good to do a water test on a regular basis, especially if you know you have hard water. If you come in one day and all of a sudden your wash is not cleaning well and you think it might be the chemistry, one of the quick ways to find out what might be wrong is look to see if your softener is not working. If your softener is not working, that could mean your chemistry is really not being effective. In essence, this next slide really shows us the effectiveness, the effects of hard water on soap. And as you can see down at the bottom, the loss of cleaning, once you get up into the 10 and 15 grain range of hardness, you're losing up to 35% of your cleaning power of your soap. So in essence, with hard water, your soap has to clean the water before it can clean the vehicle surface. So when you have really hard water, you've got a couple of choices. You can soften it, or you can put a larger tip in or turn the pump up and use more chemistry to try and counterbalance the hardness to get that cleanability. The next big topic that we always see with water is total dissolved solids, or TDS. That's pretty much everything that's in the water. Anything above 20 parts per million, 20 to 40 parts per million will begin to leave spots. Even if you have the greatest wash and the greatest chemistry in the world, if you don't have good water, it's going to leave spots. Good quality rinse water is going to be, we really like to have 20 parts per million or less. And 17.1 parts per million is 1 grain. Now that gives you the calculation and the conversion if people talk grains versus parts per million. So good quality rinse water without spots is going to be 20 parts per million. Good quality wash water that's not going to affect your chemistry in the cleaning aspect is going to be under 200 parts per million. Now, something that a lot of people really don't understand about water, hard water, soft water. The softening process does not remove the TDS, it just changes it. And as you can see on the right, you can see a bunch of letters and nomenclature. The Na is sodium, the Fe is iron. There's lots of different things. What a softener does is it exchanges. It's called an ion exchange. And a softener has sodium in the brine tank. That's salt water. And the hard calcium water comes in and it exchanges the calcium ion for the sodium ion. So you're basically exchanging the ions going from hard water to soft water, but you're not actually taking the total dissolved solids out. So you're still going to have TDS even though your water is soft. Soft water does not affect chemistry like hard water does. So the best way to, really the only way to remove TDS to get spot-free rinsing is to go through RO or reverse osmosis or deionized water or a situation of that nature. So that's total dissolved solids. Those are the two, hardness and TDS are the two big things that affect your water for chemistry and for rinsing and the balancing of the overall car wash. So as we're coming into our 45 minutes and getting ready to finish here, let's kind of summarize a little bit. It's all about the balance. It's critical that you choose the proper high pH and low pH product to make sure you're addressing the soil that you have. It's critical that you have the proper positioning of the lubrication product and the right surfactant in that lubrication product to make sure that you're cleaning, but yet late in the process, you're not hurting your drying. And then we also have to understand our water quality. Hardness is going to affect how well we clean. And the last bullet I'll leave you with is it's critical, really critical, that you find a supplier partner that understands all of this stuff that we talked about today so they can be your advocate and can be your partner to make sure that you can get the cleanest, driest, shiniest car possible and balancing the chemistry in your wash. So that finishes my presentation. Let me look and see, are there any questions? I see no questions in the question box. If anyone has a question and wants to type a question in, we would love to answer that for you. Well, if no one has any questions, we appreciate your time. We thank you for the day, and have a great weekend. And this presentation, as they said, is being recorded, and it should be made available afterwards for anyone that wants to look at it. And please feel free to reach out to us if you have any questions.
Hey, Stuart.
Yes.
It's Jenna. There's a couple questions I saw popped up on the questions bar. So Al wanted to know what the best pH level was to remove water stains.
The best pH level to remove water stains.
Yes.
It's the best pH would be a product that has a pH below 7. Obviously, depending on the type of soil, the type of water soil, and how long it's been baked onto the car, you might be able to do it with a 5 or 6 pH. But then if it's been on there really bad, you may need to take something down into the 2 or 3 range. And that could be a discussion all in its day. Hard water spots. There's a difference in hard water spots and acid rain. Acid rain actually eats away at the surface and creates that microscopic crater in the clear coat, whereas a hard water stain just is floating on top and would be a lot easier to come off with a mild acidic detergent of most any kind, probably in the 5 to 6 range.
All right, and then there's also, he has a few customers that insist that washing their car often makes their paint dull. I always respond that the proper lubrication avoids this, but is there a better scientific response?
I agree that lubrication is the key. If the wash that they're going to is not lubricating, then there could be scratches. It's an overall program, and I think we know that if you, on a regular basis, if you get your triple foam polishes with the polymer protectants in them, there's a lot of sealants out there with protection in them. There's a lot of total body protectants now out there, lava type applications that can give you protection. So if a customer washes their car on a regular basis, they're not going to dull the finish. So that's the key. Now they may be going to a wash that sometimes some washes don't use what we would say are out of balance. They don't use any low pH at all. And when they don't do that, a car just doesn't look quite as shiny after it's been washed. But in general, if you lubricate well and don't scratch, you're not going to leave a duller finish on a car.
Okay, and then a follow-up to the first one was, what makes acid rain?
What makes acid rain? Acid rain comes from exhaust, from industry, from vehicles, from cars, and things of that nature, and it gets up into the atmosphere, up into the clouds, and it's floating around there as a gas, if you will. And then when water droplets are formed through the cloud and rain and moisture process, it picks up that acidic nature and it drops it back down on the earth. And if you don't see, the problem with acid rain is that's how it really, from industrial exhaust, from manufacturing plants more than vehicles than anything, it's your industrial plants that create a good bit of acid rain. And then it gets solubilized from a gas back down onto the surface of the car. And the problem with the acid rain on your vehicle is if you get acid rain on your vehicle and you go wash it, you're in good shape because you neutralize it. But if you go, people that go 2, 3, 4, 6 months without washing their car and it has acid rain on the car, every time that it rains outside, that dried up droplet of acidic acid rain gets solubilized a little bit, making it want to start eating again until the water evaporates out of the droplet. So it's just a reoccurring process. Once the acidic nature gets attached to the surface of the car, until you go to a car wash really and get it neutralized and cleaned, it's going to keep just resolubilizing itself and eating away at that clear coat layer until it eats a crater in it.
Okay, then there's one last question. There's a reclaim company that claims they can reuse their reclaimed water for dilution with chemicals. Can you comment on this?
Yes, there's several companies out there that do reclaim, and the thing about reclaim, that gets back to the 4 types of surfactants, and there's a debate. I don't know that debate is the right word so much as struggle. There's a struggle in the industry of, on the chemistry side and on the reclaim and water treatment side, that side of the fence is always saying we need to have a dam in the pit where we can get our rinse water, specifically the mineral seal oil based sealants and drying agents, going the other way over to sewer, and tire dressing from automatic tire dressing runoff going to sewer, and all of your soaps and detergents going to reclaim. Well, as operators, you want to save every droplet of water that you can, so they want to go with no dam and put everything back in. So what many of the reclaim companies are working on and have come up with are ways to treat the water to the point that you can use it. It goes through multiple filtrations and multiple cyclonic filters and treatment and things of that nature, carbon filters and all kinds of stuff. You can really get it back to the point of you can dilute chemistry up to the point of triple foam. So all of your detergents, all your pre-soaps, wheel cleaners, lubrication soaps, and even your triple foams, a lot of times, if they have the right reclaim system, you can use that water to dilute your chemistry up to that point. But after that point, when you start talking sealants, drying agents, total body protectants, things of that nature that have that cationic surfactant that really doesn't get along with all the other, with the anionic soaps, that's where you have to draw the line, and you can't dilute your chemistry with the reclaimed water after the point of triple foam. So yes, there's several companies out there that make equipment that will get water clean to the point that you can use it up through triple foam. That was a good question, by the way. Thank you.
All right, looks like that was the last question. Thank you so much, Stuart, for your time, and thank you, everyone, for joining us on this webinar today. We'll have this available for you within the next few days, the recording as well as the slides. So everyone have a great day.
Thank you very much for your time. Have a great weekend.
Bye.